Okay, here we go, part 2. I'm going to start with number 7. These problems will not take as long as the previous ones, so here we go. This says find the zeros of each function. Now, when we talked about it, it specifically says use your algebra. So, the first thing you should do is look at this and say, aha, what can I do with this? And also it says find the zeros, which means you should let your y equal 0. So we're just going to set this equal to 0. And we're going to think algebraically, hey, what can we take out of this? Well, we can take a 2x. What would be left? X squared minus 2x minus 3. Now, are we done factoring that? I don't think we are. So that would factor into x minus 3 and x plus 1. Now we can just look at it and say, hey, what can we plug in for x to cause this to be 0? X equals negative 1. What could we plug in there? 3. This is just a classic aha, x equals 0 moment. Remember what I taught you guys, if the highest power is 3, you're going to have 3 answers. All right, let's go on to number 8. Same thing. Set this equal to 0 because that's what you're really finding. We're going to factor an x out. We'd be left with x squared minus 100. Hopefully your algebra skills remind you that that is a difference of 2 squares. Now we can solve it. What would cause that to be 0? 0. How about this one? 10. How about this one? Negative 10. And there's your 3 answers again because your highest power is a 3. Number 9 is coming at you slightly differently. They're telling you what the zeros are. So here's a 0, minus 1. So that means we know our polynomial is going to look like this. 2. That's going to be x minus 2. And then the 0 is where we always have an x in there. And that would equal f of x. Now, if they said leave it alone, specifically in the instructions, we could leave it alone. Problem is, it says with leading coefficient. Now, I know these directions don't indicate it, but we got to multiply this out. So I'm going to multiply this by foiling it. X squared, outside is negative 2x, inside is 1x, so that's minus x, and then minus 2. But now I got to multiply that by x. So doing, doing, doing. So I'd get x cubed minus x squared minus 2x equals f of x. Now, if I'm not careful and I don't listen to the instructions, I'm going to put that down as my answer and feel pretty good. Leading coefficient just means multiply all that by 2. So I'm going to get f of x equals 2x cubed minus 2x squared minus 4x. Not even sure why this is an instruction, to be perfectly honest with you, but it is, so that's what you do. All right. Number 10 is asking us to divide. All right, what we learned was we look at the bottom and we say, all right, what can we put in the cheapmunk nest? Negative 4. Now we got to be careful that these decrease linearly, and they do. Cubed, squared, 1, none. So I can just take off the coefficients. And then I can begin my synthetic division. Drop the 3 beneath the line, multiply, add. That's 8, add. That's negative 20, add. Now, what in the world is this? Well, that's my answer in kind of coded form. It's actually 3x squared minus 2x plus 5, and I always like to think of it as a plus there, plus 4, because that last thing is always your remainder, but they're asking us to leave our answer in fraction form, which means you take your remainder, put it over your divisor, and now you've put it in what's called fraction form. All right, number 11 doesn't give us a whole lot of room to work here. This says find all the zeros. And remember when we learned this, we have 2 kinds. We got rational zeros, and then we have irrational zeros. Now, what does this whole P and Q little clue have to do with this? Well, this is where we get the thing started by plus or minus P all over Q. Where do we get this from? That number. Notice I ignored the negative because there's plus or minuses in front of it. What are all the factors of 3? 1 and 3. What's the good news? There's not a big number of possibilities in the numerator. Bad news? We got a 2 here, which is our cube. So that's going to be 1 and 2. Now, I know there's not much space here, but 1 over 1 is 1. 3 over 1 is 1. So there's our first possibilities, plus or minus 1, plus or minus 3. The problem is we could also have 1 over 2, and we could also have 3 over 2. So we have to bring those along for the ride. Sometimes those are significant, sometimes they're not. But we're going to start with plugging a 1 into this original and hope that it works. I can see that it's not going to work, but let's go ahead and plug a 1 in. 1 cubed is 1 times 2 is 2. 1 squared is 1 times 5 is 5. See, we got too many positives. That is definitely not going to equal 0, so that's gone. Now we got to go plug in negative 1 and hope for the best. Negative 1 cubed is negative 1 times 2 is negative 2. Negative 1 squared is 1 times 5 is 5. Negative 1 times 3 is negative 3, minus 3. Looks like there's too many negatives for this one. Now are we really going to plug in 3? No, because if we plug 3 in here, plug 3 in here, plug 3 in here, way too many positives. There's no way that's going to equal 0. You always got to be careful with the negatives. Every now and then a negative will surprise you. Negative 3 cubed is negative 27, times 2 is negative 54, and right away I can see this is not good. But negative 3 squared is 9, 9 times 5 is 45. And then 3 times negative 3 is negative 9. And then, minus 3. See, we got too many negatives. So now we're going to have to trust that one of these fractions is going to work. Well, here we go. We got to plug in f of 1/2. Well, 1/2 cubed is actually 1/2 times 1/2 times 1/2, so that's 2 times 1/8, which is 1/4. Now, what's 1/2 times 1/2? Well, that's 1/4. So that'd be plus 5 times 1/4, which would be 5/4. Now, what's 3 times 1/2? Well, that would be 3/2, which if I found common denominators, it would be 6/4. And then minus 3 would be negative 12/4. That's from this. Well, look at this, you guys. That's 12/4. What's 12/4 minus 12/4? Holy smokes, we got a 0. So we know that one of our zeros is rational, which is going to be 1/2. Problem is, what are the other ones going to be? We don't know. But we're going to stick it in the chipmunk nest, and then we're going to put our coefficients out there. 2, 5. I told you there's not much room. Minus 3. Drop the 2 beneath it. 1/2 times 2 is 1. 1, put it here, add. 1/2 times 6 is 3, put it there, add. 1/2 times 6 is 3, put it there, add. Now this is a really good indication that you're on the right track if you have 0 remainder. But what did I teach you guys to turn this into? Well, because the original starts with a cubed, as soon as you go through synthetic division, this drops down to squared. And now, because this is a trinomial, and I'm just going to use my basic math skills, I'm going to divide this whole thing by 2. Why? Well, divisible by 2, divisible by 2, divisible by 2, so we should just do that. Again, we're running out of room big time, but I'm going to write this down over here. X squared plus 3x plus 3. And as you can see, this is not factorable. You should try it, but if I tried it, you can see that that is not going to work. So A is 1, B is 3, C is 3. We're going to plug that into quadratic formula, which I might as well just do it up here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's do it. So if b is 3, then I'm going to get negative 3 plus or minus. B squared is 9 minus 4 times a. times c all over 2a, which would just be 2. Now let's do some mental math. 4 times 1 times 3 is 12. 9 minus 12 is negative 3, so I get the square root of negative 3. And if you go back to algebra 2, I can take the I out. So this would be negative 3 plus or minus I squared of 3 all over 2. Now, as strange as this is, these are your other two answers that would accompany your first answer, which was a half. That problem takes a lot of work, no doubt about it. All right, number 12. Is x plus 1 a factor of this craziness? Well, it's kind of similar to what we did earlier, but this is like a remainder theorem. We're going to figure out what causes that to be 0, and that would be x equals negative 1. And you're just going to plug that in here and see if all of this equals 0 when added together. And if it does, then we say yes. If it doesn't, then we say no. Negative 1 to the fourth is 1. Negative 1 cubed is negative 1. Negative 1 squared, you got to follow PEMDAS, got to square it first, is 1 times negative 3 is negative 3. Negative 1 times negative 2 is 2, plus 1. Now we got to add up the negatives, that's negative 4. Add up the positives, we get positive 4. This equals 0. Therefore, there's no remainder, and therefore we can say yes, it is a factor. That's the easiest way to do that one. All right, question number 13 is designed to see if you remember the complex conjugate theorem, which, remember, if this is one of your roots, which again, what's another word for root? Answer. But if this is one of your answers, then it is implied that 2 plus the square root of 3, its conjugate. Because this is considered complex, it's assumed that its conjugate will also be a solution. And this is called a complex number 2 because of the letter I. So what's the conjugate of this one? Negative 2 plus I. These are the remaining two roots. Pretty simple if you know the darn theorem. All right. Number 14 asks us to graph this function. First thing you should start out with is your zeros. So that's going to be negative 2. That's going to be negative 1. That right there is going to be positive 1. There's my zeros. The next thought, so label your zeros. Number 2, you're going to ask yourself, is this a cubic or is this a quartic? And if you think, all right, what's x times x squared? That would be x to the fourth, so it's a quartic. But if you notice, it's not a cubic, it's a quartic, but if we look at this, we could also say that a is less than 0. The leading coefficient, that's what a is negative. That's what this says. So a quartic, if a is positive, remember I taught you winners are positive, but this is a negative one. Now this is politically incorrect, but students remember it. Negative people are morons. All right, that's just a memory tool. Don't take offense to it. But there's another clue. You see this 2 right here? That means it bounces off at negative 2. So I got to capture this drawing while also remembering that it bounces off at negative 2. So I know it's going to go down from the left because of this. I know it's going to go down to the right because of this. I also know that it bounces off here. So it's going to go up, and it's either going to go really low, very not low at all, really low, or really, really low. I don't know. So I need to figure that out. Well, if this is negative 1, and if this is negative 2, then I need to figure out what f of negative 1.5 is. This is where the work comes in. So I'm going to plug it in here. So I'm going to get negative 1.5 minus 1, negative 1.5 plus 1, and then negative 1.5 plus 2 squared. All right, so not going to forget about that negative, but this would be negative 2.5. This right here would be negative 0.5.